Hello. Hello. Hi, everyone. Can you hear me?
Yes,
Yeah. Hello. How are you? Hello.
good.
Audible.
Yeah, I'm good. Thank you. Okay. So we are going to start Java full stack. Okay. So this is the first meeting you are attending, right? Yeah. For Java full stack. Hello.
Yes.
Yeah. Okay. So this is a quick, understanding of what is programming, and then we see installation, and then uh, start writing code. Start from basic, coding knowledge. Okay. So programming is is all about dealing with two important things, which is data and operations. Okay.
I think programming intro this everything completed. I think so.
Completed, right? Okay.
Yes,
Okay, you attended. Okay.
that is demo session. Demo
Demo
completed.
session. Okay.
Demo
Yeah.
we completed.
So installation links also have shared, right?
Yes,
And have you installed on your machines?
yes.
Yeah. Great. So are there any Mac users? Uh,
Yeah, I am.
yes. Are you using Mac OS?
Yeah, I'm using Mac OS.
Have you installed Java on your machine?
Yes, I do.
Yeah. Okay. So maybe you can use this link. Okay. This is official website. Okay. JDK 17. You can find all links for different operating systems. Okay. So if you have done, no issues. Okay. Eclipse also, I think all of you have installed, right?
Yes, you gave JDK and Eclipse both links.
Eclipse, yeah, Eclipse, there are other IDEs like, IntelliJ. Nowadays, many people are using IntelliJ also. There are other IDEs like, VS Code, but Eclipse is more powerful than any other IDE. Okay. Just look wise, IntelliJ may be better, but when it comes to practical, the way we use and the shortcuts and the other plugin support is more for Eclipse. So if you use Eclipse, you will learn different shortcuts and code generation plugins, shortcuts, tools. There are so many advantages if you use Eclipse. Okay, Eclipse we can, beginners can use and professionals will use Eclipse. IntelliJ only beginners will use. Okay, if you want to, if you want to write some advanced level of coding, definitely people should go for Eclipse. In future, people will definitely shift to Eclipse, those who are using IntelliJ. Okay, so I'm going to start using Eclipse. Eclipse is easy. It's for both beginners and professionals. Okay, so you can download Eclipse. I have already shared link. Okay, Eclipse for Java SE. Okay, you will get official web page link. It is available for all operating systems. You can click on the newer package available here, and there are different versions here. Okay, released in 2024 here. You can click any one of the first three and just click there and just scroll down, and you can find links Windows, Mac OS, Linux. You can install it, download and install it. Okay. I think all of you have done this, I believe, right? Okay. So let's start understanding JDK, Java software. Java software is called JDK, Java Development Kit. Okay. JDK is one which we have downloaded and installed. Let's try to understand different parts of JDK. This all theory have nothing to do when it comes to coding, but just to have some knowledge on what are the different parts of JDK software we have installed. So let's have a look at it. JDK has two main parts. This is the very big diagram in the official website. It's very difficult for a beginner to understand. I'm just trying to make it okay, easy. Okay. So first one is Java tools. Java tools are used for compilation, execution, and creating other application files, applying some security policies. Okay, and there are so many other uses like documentation. Okay, if you want to generate documentation, you use one tool. For compilation, another tool. Okay, for creating application, we use other tool. There are so many tools. Okay, available. All the tools you can find it in JDK home directory. Okay, there is a directory called bin. In bin directory, you will find all the tools. Okay, this is the first part of JDK, and the second part of JDK is Java runtime environment. Okay, JRE. Okay, JRE, Java runtime environment. So JRE has two parts again. Okay, one is JVM and the other one is Java API. These two together, okay, makes it, it creates JRE, runtime environment. This is JVM, Java Virtual Machine. Okay, Java Virtual Machine, and this one, the next one is Java API. Java API or Java library, you can say. Okay, so these two together creates a runtime environment. Okay, these are the parts. If you have a look at official website, you'll find same diagram, but more details you'll find. For example, Java API. Java API, there are different package names. All the package names will be there. Okay, so in Java tools, you'll find some tool names that are available. So I just gave here Java tools. Okay, you can find all the tools from the installation directory. Okay, so JRE, uh, when we start executing programs, okay, JRE is going to be active. So there is a tool which will invoke JRE for the execution of programs. JVM, Java Virtual Machine, and Java API. These two together. Suppose if any one of them is missing. For example, if anything is missing in Java API, it is not possible to execute Java program. The relation between JVM and API is, okay, if I tell you some general example in a vehicle, okay, engine and fuel, right? So can engine run without fuel? No, right? Engine is good, but there is no fuel. It cannot run. So you can think of JVM as an engine and API is fuel, and fuel must be available to the engine to run. Okay. Same way, JVM and API together creates a runtime environment. Then it takes your programs, all the programs written by developers, and execute it. Java cannot be Java programs cannot be executed without Java software. C programs can be executed without C software. C++ programs can be executed without C++ software. Maybe at the time of development, we need C++. At the time of development of C program, we need C. But once we execute it, we don't need uh, C software to execute C program from the second time. Okay, because they are all platform dependent, C, C++. This is platform independent. Okay, platform is operating system here. So every operating system, both developers and clients must have Java software. Developer will use tools to develop Java code, and clients will use GRE. In official website, you will find two links: download JDK and the other one is download GRE. You can download only GRE also. When you install GRE, you're not going to find tools as part of that because GRE will be used by clients only. They are not going to develop anything. They are not going to edit code. That's the reason why they don't need any tools. Who use tools? Only developers. They need tools to fix any problem, to add a feature, to remove feature. Tools are required. Okay, clear? Yeah. So execution of Java programs, there are steps. First, we write .java files. We create .java files here. Okay. .java, say hello.java, whatever it is, like hello.java or anything, welcome.java, product.java, student.java, employee.java. We create any file with the .java extension. .java is the secondary name of the file. So this is the source file. Okay, this is the source code it contains. Okay, this contains some source code, and this will be passed to the compiler, Java compiler. Java compiler is a translator, converter, language converter. Okay, compilers, interpreters are language converters. It converts high level to a low level. Compiler, it's also a program. Okay, it is also like other programs. Input to the compiler is .java file, and if there is input, definitely there should be some output. Every program Even addition of two numbers program contain input and output. For addition of two numbers, input is two numbers, output is the sum of those two numbers. Same way, compiler is also a program which takes input, that is .java file, and which gives output. The output of this is dot class file. So the file name will be hello.class. This class file contains bytecode. Bytecode, or this is intermediate code. This bytecode cannot be executed by any other software other than JVM. If there is no Java installed, then it is not possible to execute. JRE is required to execute hello.class file. Contains bytecode. Okay. And this hello.class file will be passed to JVM on different operating system. You can use any operating system, it doesn't matter. Bytecode is independent of the JVMs that are running on different operating systems. So bytecode remains same. It's intermediate code. Okay. So JRE will execute it, and then we get output from JRE here. Okay, we get output here. So using this one. Okay, clear? You got any questions, any doubts? Let me know. Yes, is this clear so far? Hello? Yeah. Can you hear me, people? Are you there?
Yes, sir. Clear.
Sir, can you please repeat about the compiler? What does compiler do?
Sure. No, there are language converters, not spoken language converters. I'm talking about there are spoken language converters also there. In programming language, there are language converters. Okay. So language converters will actually convert from uh, you know, one format to other format, one code to the some other type of code. Like most of the cases, it is source code to machine code. Okay. Every programming language will use language converter. There is no programming language which is not using language converter. Okay. Reason why we should use is we write high level language code. High level language cannot be understood by machine. Machine will understand machine code. If it is Java, maybe JVM can understand bytecode. If it is Windows operating system, Windows has a different format to understand. Every instruction should be converted to some you know Windows understandable. There is something called MZ format that Windows use, and Linux use some other format. Mac use different format. So without language converters, it is not possible to pass the message or pass the instruction in operating system understandable format. So there are two types of language converters. One is compiler and other one is interpreter. Okay. Interpreters convert. There are some languages use both compiler and interpreter, and some other languages use only compiler, and some other programming languages use only interpreter, no compiler. For example, Java. Java uses both compiler and interpreter. C language will use only compiler, no interpreter. C++ only compiler, no interpreter. JavaScript will use only interpreter, no compiler. Python. Python will use only interpreter, no compiler. It depends on design of the language. Okay, they decide whether to use compiler or interpreter. Java uses both compiler and interpreter. To convert .java file to .class file, compiler will be used. .class file cannot be understood by operating system directly. Then again, interpreter will take that byte code. Java interpreter means interpreter is not same for all the programming language. It's also a program. Python interpreter is different, and Java interpreter is different. JavaScript interpreter is different. JavaScript interpreter is part of browser. Google Chrome, Firefox. Okay, all those browsers have interpreter, JavaScript interpreter as part of browser. Okay, so use of compilers and interpreters in Java is compiler will convert source code to bytecode. Interpreter will convert bytecode to the machine code that machine can understand. If it is Windows operating system, it will translate to a a format that Windows can understand and then execute it. Okay, these are all programs written by experts in order to convert instructions from one format to other format. This is clear. Without language converters, it is impossible to execute any uh, program, any technology you may use. Language converters are required. There is a difference between compiler and interpreter. Anyhow, common thing is both are converting. Compiler will be much faster compared to interpreter. Compiler will convert all the programming instructions at a time. Okay, this interpreter will take it is slower because it takes one by one, instruction by instruction. It will convert. That is the reason why it is slower. So interpreted languages are bit slower compared to languages that are using compiler. It doesn't matter. Okay, the output remains same. There is no impact on output. There is no change in output. Okay, compared to languages that are using compiler and languages that are using interpreter. There is no change in output. Okay, clear. So the basic elements of coding start with the fundamental elements of coding, where we discuss operators, variables. Okay, let me start with very basic things here. Operators, variables, data types. Okay, and then we try to understand structure of Java program. So we should remember the structure and we should follow the structure of the program because structural code, structural code we can generate, logical code we cannot generate. So there are powerful IDEs nowadays which will help to generate structural code without any errors. So structure of Java program, we'll try to understand. Okay, and we follow the same structure for every different program. Every that means maybe the input output may be different, but structure remains same. Logic can be different. So let's try to understand these, step by step. For data types, we deal with different type of data elements in program. Like there is a categorization of data that contains only numbers, and there is another category of data which contains only alphabets. Okay, uh, there are another category of numbers contains exact values. Okay, so rounded values is the one category. Exact values, we have another category of data type. Okay, alphabets, combination of symbols, digits. Okay, let's try to understand different data types present in Java. Okay, data types here. There are data types to store rounded values like integer values. Okay, rounded values I can say here. Okay, rounded values. There are different data types with different sizes here. It depends on requirement we use. One is byte and short. Okay, int, long. These are four data types to store rounded values. Rounded values like 1, 10, okay, 20, 100, okay, any value, okay, with no decimal point, no fractional part those numbers. Okay, so most frequently used data type in Java is integer. Integer is most frequently used. Okay, in rare cases we use byte, short, long. Long we use when we want to specify time in milliseconds. Then we use long because it will be a big number. Okay, short, byte, these two are not recommended to use. Okay, if we use them, then explicit type conversion will be required, and this will lead to some problems also. So don't use byte, short. Always use integer. Okay, so you can store rounded values like uh, you know say, let me show you examples here. Say 10, 30, 400. Okay, something like this. You can store rounded numbers. The other one is the exact values. To store exact values, we use two data types, that is float and double, to store exact values. Okay, there are two, float and double. All these are beginning with a small letter. Remember, long, L, small. All the data types begins with the small letter. If we use capital, again it will be different, slightly different. So we'll see what is the difference later. So float and double. Here we have these two data types for storing exact values. Always use double, never use float. Float will not give you exact result when you calculate percentages. Double uh, will give you correct value. Okay. So always use double. Some examples like you can store, 3.14. Okay. Thing like this, you know. Okay. Number of digits in fractional part in float is less than the number of digits in uh, fractional part of double. Okay. So this will float will quickly round it to the next number. So when it quickly round it to the next number, then there are chances that we may get wrong results. This will not happen. Double will not do that way. So it will give you exact value. So the difference is the number of digits in fractional part are different in float and double. So that definitely make difference in calculation. So that is the reason why I always use double. Here in rounded values use integer and for exact values use double. Okay. And the other data types in Java, you can use Boolean type to store true or false. Okay, Boolean type. This will store either true or false. Next one is to store some characters. To store characters, single character, we use char type to store a character. Any alphabet you can store using char type, char. Any one character it can store, one character, not more than one. Here it can be, that character can be any alphabet, it can be digit or it can be symbol. Okay, any one character it can store or letter. Okay, so example, it can be, we have to specify it in single quotes, like A, A is in single quotes here. Okay, alphabet. If it is digit, that digit should be in single quote. Two, this is one character. Two is another one. We can also specify a symbol. Like I want to use plus in single quote. Plus is also a special character there. So we can store uh, alphabets, digits, and special characters. Okay, you will understand more details when I start using this in coding. Okay, you may not understand this now completely. Maybe okay. Once I start using it, okay, then you will know more details about it. You just need to remember all these things for now. Okay. So there are different data elements we need in a program, and we are going to process those data elements. And after processing, we get some output, and we are going to print the output. So to store data elements, these are the data types will help. Okay, and we can use this in our programs. Character type. Okay, Boolean type, uh, float, double, and there are four data types to store rounded values. These are all keywords. Byte, short, int, long. These are all keywords. Keywords are reserved words. So we cannot use this word for any other purpose. it is already defined purpose of these words. That is the reason why we can call it as reserved words or keywords of Java. Okay. Clear? Data types. Yeah, these are data types, and we'll try to understand operators. Operators are symbols. Operator is a symbol that has some action. Every symbol has some action to do. So what are the symbols that we use and what are the operations we can perform using operators? Operators will perform some operation. Okay. So there are classification of operators: arithmetic, relational, logical, okay, ternary, assignment. There are different types of operators present in Java. We'll try to understand arithmetic operators first. Arithmetic operators: plus for addition, minus for difference. You can find difference two numbers. Okay, subtraction, multiplication we use asterisk, and for division we use slash, forward slash, and for modulus operation we use percent. Difference between slash means division and modulus operation is both will perform same operation, but the output is different. If we divide, okay, numbers, a divided by b, if you want quotient you can use slash. If you want remainder, then you can use modulus. For division, we got two results, right? So it depends on what we want. We use operator. To get quotient, we can use forward slash. To get remainder, we can use percent. Okay. Next, there are logical, relational. First, we'll see relational operators. Relational operators are useful for comparison. For comparison, operators are less than, greater than, less than or equal to, greater than or equal to, and not equal to. Okay. So after comparison, the result can be either true or false. So we should know what type of result we are going to get after particular operation. For example, if there are arithmetic operators, what is the type of result we are going to get? See, we already discussed the data types, right? Boolean type, and for rounded values we have byte, short, int, long. So when we perform any operation here, for example, plus, what is the type of result are we going to get when we try to perform addition? 10 is one value, 20 is another value. 10 is integer type, 20 is also integer type. So integer plus integer, 10 plus 20, we get 30. What is the type of 30? 30 is also integer. So when we try to perform arithmetic operators, the type of result that we are going to get, not the exact value I'm talking about, the type of value. Okay, there are two things, type and value. If there is 10, value 10, then the type of that 10 is integer and value is 10. Okay, so after arithmetic operations, we may get the type of result. It can be int type of result we may get, or we may get double type result. As we discussed example 10 plus 20. 10 is integer plus 20 is integer. Result is 30. 30 is also integer. Okay, if you give 1.5 plus 1.5, 1.5 is double plus again double equal to double result we get. So either int or double result we are going to get when we try to perform arithmetic operations. Same way, when we try to perform relational operation, the result can be either true or false. We don't get anything other than true or false. So for example, 10 less than 20. 10 is integer type, 20 is also integer, but here there is a less than. 10 less than 20, it is true. We are going to get true. If I write 10 greater than 20, this will result in false. For beginners, there is a tool you can use called JShell, which is available from JDK 9 version. Okay, in JDK 17, it will be there. So if you want to quickly start writing some simple expression, see the result of the expression, I'll show you one very useful tool, especially for beginners. After installation, just go to installation directory in C drive. Maybe it is installed in C drive by default. Program files. Okay, and there will be Java. Okay, in Java JDK 17. JDK 17. There is a bin directory. So in this bin directory, I told you in the beginning of this session that there are two parts of JDK. One is Java tools, another one is GRE, right? All the tools are present in bin directory, I said. So this bin directory contains all the tools required, okay, to develop software. So open this bin directory. Okay, JDK 17 bin directory. In this bin directory, you will find a tool called JShell. There are so many tools here. To find it quickly, you can just click somewhere and type JSH. It will show you JShell directly. Okay, so here JShell is there. So I'm going to double click on this JShell. Okay, double click. Yeah, welcome to JShell version 17.0.4. Okay, now we can see JShell prompt here. So this is the one which will help me to execute any particular Java instruction and see the output instantly. I don't need to write a lengthy program. I don't need to follow the structure of the whole program to see the output of particular line. So, okay, so I can quickly type some expression and see the output immediately, and okay, we can understand how it is working, and I can quickly decide whether can I use it or not. So does it help me or not? I can figure it out. So say I want to check addition of two numbers quickly without writing a structure of Java program. So just 10 plus 20, enter. Immediately next line you get the output. Okay. So 10 less than 20. What is the result of 10 less than 20? 10 less than 20, enter. True. 10 greater than 20. To see that, see the output. 10 greater than 20, enter. False. Any expression you can type here and check the result of that expression, see how it is working, what is the output we are getting. Okay, before you use it in your program, you can do lot of experiments using this J shell, and you can understand different parts of the program separately, different expressions of the program separately before you use it in your program. Okay, clear? So it is good practice to use J shell. You can have J shell window, okay, and open, and the other Eclipse IDE open while typing code. You may get some doubts on expressions, how this is going to work. I want to know before I use it, I want to know how it is going to work. So I'm going to use it in Eclipse, but I want to know how it's going to work. So switch to J shell window, just type there and check how it is working. Okay, if it is giving me expected output, then I can use the same expression in Eclipse and I continue writing code. That way, okay, it will help. Okay. You can write some expressions like 10 equal to 10. This will return true, right? So you can write less than or equal to, greater than or equal to. So what is the output of this one? Less than or equal to 10. Can you guess the output of this one? Can anyone guess? 10 less than or equal to 10. What is the result?
True.
True. 10 greater than or equal to 10?
True.
True. So suppose if I have some doubt how it's going to work. So I have J shell here. So 10 less than or equal to 10. True. 10 greater than equal to 10. True. Okay, I know how it works. Then I can confidently use in my program. I can use this code. If you want to print any message, just print message, or print instruction, message using some print instruction, that is system dot s capital out dot print ln or print okay, uh, double quotes hello world, double quotes close, close parenthesis, semicolon optional. If you want to use, you can use here, but it is compulsive in coding, that here it is optional. You got hello world here. Generally, to get this in Eclipse, we have to write minimum 6 lines of code to get hello world. We create a class and we open class block and then main method, open main method block, system.out.println, close main method block and close class. A lot of structural code and then we add logical code and we to see simple output. Here we can quickly type that statement that we want to see the output of that. We can get immediately. This is for learners. This is not for you cannot develop. No one can develop a software using JShell, but everyone can learn Java using JShell. This is one of the useful tools for learners to learn Java quickly. These kind of tools are there for Python and JavaScript a very long time. Okay, we have this tool in Java from JDK 9 version. In JDK 8, you won't find this. Okay, these are relational operators. Okay, and the other category of operators are logical operators. Logical operators. There are three logical operators. We use symbols there. Symbols will definitely decrease the readability of the code. We should use it because we don't have any other option here. Double and symbol for logical and for logical or double pipe symbol. Okay. And for not, exclamation mark for not, and or not. These three are logical operators. These are there in every language. Every language supports arithmetic, relational, logical, assignment, ternary, most of the languages. So and or is to join two relational expressions and then get one result. Okay. So and the all the relational expressions, all the individual relational expressions should evaluate to true to get final result as true. So and says all, and means all the expressions must be true. Or says any one of them should be true to get final result as true. This is same as we use some sentences in spoken languages like, yeah, when I want both, then I can say and A and B. Okay, I want pen and paper to write something. I want both. When I when I need only one of them to continue my work, I can use or. I need pen or pencil, right? The way we use these and or not in our spoken language, same way we can use it in program. Okay, let me show you one example. 10 less than 20 is one expression, and another relational expression is 20 less than 40. These two are different relational expressions, two different relational expressions. Now, I want to join these two relational expressions and make it one. So I can join these two using and, or I can join these two using or. For example, 10 less than 20 and, okay, 20 less than 40. So when I use and, then the first condition must be true and second condition should be true to get final result as true. Okay, the output will be true here because It will first evaluate the individual relational expressions. True, untrue is true. First one is false, second one is true. False, untrue. What is the result? First one is false, second one is true.
True. End of rest is false.
And says all must be true to get final result as true. First one is false, second one is true.
False.
It is false. Why it is false? Because the first one is false and says all must be true to get final result as true. Remember, and means all the expressions. Suppose you have a doubt, how it's going to work. Is it correct or not? I can copy this. I have J shell. Now I can quickly type something in J shell here. Okay, 10 less than 20 and 40 less than 50. It is true. So let me give first one greater than. Okay, first one is false, second one is true. Now the output will be false, right? We can use any number of relational expressions to join them using and. Like you can write 10 less than 20 and 20 less than 40 and 40 less than 50. You can write a lengthy expression using and relational and logical operator. Relational less than is a relational operator and is the logical operator. Yeah. Okay. Or there is another logical operator called or. Or is to we use or when we want, if any one of them is true, it is okay for me to continue. Okay, then we can use or 10 less than 20 or 20 less than 40. What is the result of this one? First one is true, second one is also true. So the output will be true. First one is false. 10 greater than 20, false. And 20 less than 40, 20 less than 40 is true. First one is false, second one is true. What will be the result of this expression here? Yeah, you can guess. Hello? Yeah, are you there? First one is false, false, and the next one is true. Or if any one of them is true, then the final result will be true. This will give true. So if you want to check quickly, yeah, J shell is there. Immediately you can check 10 less than 20 or 20 less than 40. Okay, and I want to change it to uh, greater than 10 greater than 20 is false, but 20 less than 40 is true. So now we have first one false, second one is true. So as second one is true, we have or. So or says any one is enough to continue. So this will give true. You might have studied truth tables, right? Yes or no? Not. Not is, it is opposite to what it is there already. Not. Not true. Not true is false. Not false is can you hear me, people? Yeah, are you there?
Yes,
Yeah, not false equal to
true,
true. Not true is equal to
false.
false. It is same as the way we use in not in spoken language also. Like for example, it did not pass the exam. What does it mean? Not passed equal to failed. Not failed equal to
Pause.
passed. Okay. Here 10 less than 20 is true. 10 less than 20 is true. Now apply not. Not, I'm using a parenthesis, putting it in a parenthesis. Okay. Uh, 10 less than 20. Not 10 less than 20 is false. We are applying not. Not true is equal to false. If you already false expression, apply not to get true. For example, 10 greater than 20 is false. Now apply not to the same expression to get true. So not 10 greater than 20, not false equal to true. You can also type simply not true is equal to false. Not false. Not false equal to true. Now guess the output of this one. Not true. What is the output of this? Double not.
True.
True. Double negative is positive. Got it? Are you following? What is the result of this one? Just tell me the result of these three expressions. Anyone?
False, false,
True.
true.
First one is false. 10 less than 20 is true. Not true is false. Okay. Next, 10 equal to 10 true, but we are applying not. Not true is equal to false. Okay. Next, 10 greater than 20 is false. 10 is actually lesser, but here it is greater. So 10 greater than 20 is false. Not false. Not false equal to This is clear, everyone? Are you able to understand, right?
Yes.
Yes.
Yes. So these are the operators we are going to use. But when we take a problem statement, how to use operator, like which operator I should use, and how can I get expected output? We have to think before we use particular operator or a combination of operators. Okay. Yeah. So the other part is, we have variables. Variable is a name for a memory location. It is very simple to understand variables in programming. Variable is simply a name for a memory location. Memory location has a name. We want to get some value from the location, we use that name to get that memory location has some address. Okay, it is a 6-digit number or 8-digit number. It depends on RAM capacity. It will be all variables store some value. Those values are some in temporary memory cells. Every memory cell has some address. That address can be a 6-digit number or 8-digit number or 10-digit number, depending on the RAM capacity. If RAM capacity is very big, then we get some big number to point to that memory location. So anyhow, for all the programmers, for humans especially, to if you want to remember anything, it is easy for humans to remember anything with a name. Okay, remembering numbers is very difficult. Okay, generally, when we meet, new people, when we want to be in touch with them, then we take their contact number and we save it with a name, right? And contact numbers. We have contacts, mobile contacts. We have a name for every contact. You have a name. Because when we associate with the name, then we are going to quickly find that contact number with the help of name and we use it. Same way, we have some data elements in our program. So I don't want to remember the number or value directly. I want to assign a name and I use name. It will internally use value which is associated or assigned to that name. To create variable can store one value at a time. Okay, variable can store one value. One variable can store one value. Okay, so if you want to 10 values, then you have to use 10 variables. If you want to store 100 values, then we have to use 100 variables. We cannot store more than one value in one variable. A variable is a name for a memory location, can store one value at a time. So to declare, to use variables, we can simply follow syntax. Syntax is data type, variable name. Okay, this is for declaration. Variable declaration syntax. Okay, and variable initialization. In variable initialization, we use variable name variable name is equal to is assignment operator, then we assign a value, or we can write expression. Variable name is equal to value or expression. Let me show you one example. And I said naming is very, very important in coding. For example, I want to store age of a person. To store age of a person, age is a number between 1 to 100. So numbers, which is a rounded number. So if it is a rounded number, I can use integer. So data type is integer. Now what I'm going to store there is age. So I use variable name is age. I want to store age and variable name is also age. Okay, semicolon. Done. This is the example of variable declaration. I want to store salary of particular employee. Salary, if it is a rounded value, then okay, it is fine. If there's a fractional part, then I have to use double. So double is the data type that I need to store salary. But variable name to store salary, I use salary as the variable name. Okay, semicolon. Done. Okay, I want to store marks of first subject. To store marks of first subject, marks are between 1 to 100. 1 to 100, I can store them using integer. So int type marks is marks semicolon. This is a variable declaration. Now I want to store true or false. Okay. So I want to store true or false. True or false. True. What is that? True indicates. What is that? False indicates. You may ask. For example, I want to store something which indicates whether employee is eligible for loan or not. Okay. Or person is eligible for vote or not. Okay. So when we have some data which indicates yes or no kind of data I have, yes or no, it just says yes or no, nothing else other than that. For example, eligible or not. If eligible, yes. Otherwise, no. So yes or no, I cannot have in my program. Instead of yes, I can store true. True means yes. Okay. Then false indicates no. Okay. I want to store some data with respect to employee. The employee married or not, for example. So to store data of employee, there is one data element which should tell me whether the employee married or not. So to store that data, I use Boolean. So Boolean variable should begin with is most of the cases. So is married. Variable name is married. Boolean is married. If employee married, then we store true there. If employee is not married, then we store false. Same way for some employees to check whether they are eligible for loan based on some conditions. I want to have some data who is eligible for loan, who is not eligible for loan. So Boolean is eligible. Boolean is eligible. If that person is eligible, then we store true. That person is not eligible, that employee is not eligible for loan, then we store false. True or false? Yes or no? There is nothing other than these two. I have some student data. So after evaluation, there will be result. Pass or fail. There is no other option. Only two options are there. So pass or fail. So is pass. You can take some variable name. Okay. Is eligible. Okay. There are many cases we can use Boolean. Okay. When we have only two values as a result, then use Boolean. Is this clear, everyone? Yeah. Hello?
Yeah, it is clear.
Yeah. So, yeah, we'll stop for the day. We'll continue next meeting. Okay. I took more time. You have any questions before we wind up the
Thank
meeting?
you.
So, yeah, thank you so much.